weak acids में थे. अच्छा, we did the ionization of water. I told you that water ionizes and it forms an equilibrium, forms H plus 1 and OH ions. So the equilibrium constant is product concentration divided by reactant concentration, which gives you this. And we did the value of Kw. The concentration of H plus 1 and OH ions is very less. So that's why 1 times 10 power minus 7 times 1 times 10 power minus 7, that gives you Kw has a value of 1 times 10 power minus 14. और मैं explain किया था कि always Kw is always constant, 1 times 10 power minus 14. Whether H plus 1 goes up, OH ions go down. H plus 1 go down, OH ions by default they're more in number. So Kw would always come out to be 1 times 10 power minus 14 whole square Dm minus x. And then we took the log of that, negative log of that. When we took the negative log of this thing, so हमारे पास आया कि this comes out to be 14. This comes out to be negative log of OH. This comes out to be negative log of H plus 1. And that is known as pH. Negative log is B. So pH plus pOH is equal to 14. We came up with this identity, and then we tried calculating the pH of strong acids. It was simple. If you know the concentration of H plus 1, you can just take the negative log of that, and you'll get the pH. So ये था, और bases का भी we found the pH of bases, that if you want to find the pH of a base, so you don't find the pH of the base, you find the pOH of the base. You know the OH ion concentration, you take the negative log of that and you get pOH. pOH निकालने के बाद all you have to do is just subtract from 14 and you'll get pH. So that was what we did, and then we started talking about weak acids, and I think we just started talking about weak acids. Okay, strong acids were easy. Okay, it was very easy to calculate H plus 1 concentration. Why? Because they fully ionize. Okay, HCl है, तो H plus 1 उतना ही होगा. Weak acids, I told you, were organic acids, acid salts. Okay, these were weak acids. Organic acids, carboxylic acid, they were all weak acids. They would partially ionize. Acid salts का मैंने थोड़ा सा डिस्कस किया था कि acid salts are when an acid does not completely get neutralized. H3PO4 है, and there are still some H left. Na3PO4 is the complete salt. So ये सब हमने discuss किया था, and I told you that when you have phosphoric acid, or whenever you have a diprotic or a triprotic acid, these are acids that can release more than one H plus 1 ions. Just like H2SO4 that is a diprotic acid. H3PO4 that's a triprotic acid, or इसको tribasic भी कहते हैं. ठीक है, it can release 3 H plus 1 ions. Now whenever you have this, what happens is that the H plus 1 I told you get released in steps. If phosphoric acid, it's going to one by one release the H plus 1 ions. So whenever you have a triprotic or diprotic, or like whenever an acid has more than one H plus 1 ions, think of it as 3 acids. You'll have phosphoric acid, it's going to release an H plus 1. Then once that happens, there's going to be another ion. That is the one that's going to release another H plus 1 ions. And then there's going to be another ion which will be formed, and that will then release another H plus 1 ions. So think of these as 3 separate acids instead of thinking of it as phosphoric acid. There'll be 3 separate dissociations. Or har dafa dissociation becomes more difficult because it's much harder for a negative ion to actually lose H plus 1 ions. क्योंकि वो तो उल्टा attract करता है उसको, ठीक है? So it's a lot harder for it to lose H plus 1 ions. But anyways, we came to this point, and I told you that from now on, ये किसके October November? Just 1 second. Topical past papers अभी कर रहे हैं. In a separate class I'm doing yearly for October November. So क्या हुआ है? People are not. So just 1 second. Let's go. अच्छा इस पार्ट में था I told you okay from now on any asset I'm going to model it as hx ठीक है I'm going to call it hx I'm going to say कि poetry किधर है क्या मेरा अच्छा so just 1 second अच्छा so from now on all assets will be thought of as hx and they will release just one h plus one ions and साथ कुछ भी बन जाएगा ठीक है some negative ion right and I told you this was the actual equation which is that an acid releases an H plus 1 that H plus 1 gets grabbed by the water molecule and it turns into H3O plus 1 so जिसको हम H plus 1 कहते हैं that's in reality that's your H3O plus 1 but we'll stick we can use either one of the equations they're kind of the same. So phosphoric acid, you're not going to think of it as 3 H plus 1 ions. The equation will be phosphoric acid releases 1 H plus 1 ions. Then you have this. This releases another H plus 1 ion. So it's the same exact equation, which is what that you've got HX and that ionizes and ends up releasing an H plus 1 ion. Okay, so it ends up releasing an H plus 1 ion and some random negative ion, whatever that negative ion is, we don't care. Okay, but this is how the equation is going to be modeled for every weak acid. And it's going to be partial ionization, which means that it's not going to fully ionize. Masla sare ye ke strong acid pe it was very easy to find out H plus 1 concentration. Now, if this is 0.1 mole per dm cube, like this is 0.25 mole per dm cube, then it's not going to fully ionize. So the concentration of H plus 1 is going to be a lot less than 0.25 mole per dm cube. But anyways, that's how equations are going to be modeled. And if you think of this, since it's an equilibrium reaction, so that involves Kc. What is Kc? Kc is the concentration of the products divided by the reactant. So what are your products? It's H plus 1 concentration into your X minus 1, this random negative ion concentration. Yeah, that's what divided by your reactant. And what are your reactants? Your reactants in this case is HX. इस वाले पे अगर करूं if I use this equation, it's going to be kind of the same. It's going to be Kc will be product concentration, so it's going to be X minus 1 concentration times H3O plus 1 concentration, which is basically H plus 1. And it's going to get divided by your reactant concentration, which in this case will be HX times the water concentration. So, and remember, water is in excess. In aqueous solution, water is taken as 1. So water will not be written in the expression. So you'll kind of get the same expression. Or what you can say is that since it's a constant, since water's concentration is constant, anything in large excess, its concentration is considered to be constant. So आप क्या करते हो? आप इसको Kc के साथ ही मिला देते हो. Or you can just write it as 1. I mean, that's what you do. You think of it as a constant. So you pick this up and you remove it from the expression. इसको जैसे उठाओगे इसके साथ जोड़ दोगे that's about it. So you kind of get exactly the same expression, and this thing is known as Ka. ये जो चीज है ना, that's this entire thing that's known as Ka. Yup, इसको भी आप मतलब और जो simplified expression which is kind of the same expression, that's this Kc is basically known as Ka. So there's no difference between them. It's just that one was a more detailed equation, the other one was a more simplified equation, but it's kind of the same thing. It's H+1 concentration into X-1 concentration divided by the acid concentration. Okay? And you're going to call this dissociation constant of the acid. And it always applies to the weak acid. So that's your dissociation constant Ka. Or so hopefully this is clear that every weak acid, अगर मैं ethanoic acid भी any propanoic acid पे formula apply करता हूँ, it's going to look like this. It's so I've got propanoic acid, which is, let's say, CH3CH2 COOH. That's HX. It's going to ionize. It's going to produce an H+1 ion, and it's going to produce a negative ion of propanoate, which is CH3 CH2 COO-1. ठीक है, और इसका फिर आपने Ka निकाला है. So K is basically the Kc for this expression. It's going to be H+1 concentration into CH3 CH2 CO-1 concentration, and the whole thing gets divided by the acid concentration, which is in this case CH3 CH2. So every dissociation, every weak acid dissociation will have a Ka value. You get this propanoic acid will have a Ka value. वो जो ऊपर हमने बनाया था ना, इसको अगर मैं कॉपी कर लूँ, it's this one. So that's also in the form of HX dissociating to form H+1 and X-1. Okay? So I can apply the same expression to this one as well. That's the equation. So this one is also going to have a Ka value. It's going to be what? K will be H+1 concentration into HPO4-2 concentration and the whole thing gets divided by H2PO4-1 concentration. So same thing, so it applies to any weak acid that's dissociating, or you can, if it's going to be a weak acid, this is going to be a reversible sign. Instead of one arrow, it's going to be reversible. It's all going to fully ionize. So you clear as okay, what K is and how do you apply K, like the expression of K. Is this clear? And is this clear, Disha? See, are we clear? So anyways, that's your K. अब अगर K का पता लग गया, what's important is how do you apply? I mean, we know K. K का unit क्या होगा? It's going to be concentration times concentration and divided by concentration. So the unit is concentration. Actually, it's going to be mole per dm cube, and it's always going to be mole per dm cube because it's always going to be exactly the same expression. So the mole per dm cube ही आएगा, ठीक है? वो देख लो, mole per dm cube into mole per dm cube and divided by mole per dm cube. You're going to get mole per dm cube. It's for weak acids only. Yeah? It's only for weak acids because that only they end up forming an equilibrium. When they dissociate, they produce an H+1, but not a lot of them. So it's going to be forward and backward both happening. So that's why you've got an equilibrium. The other thing is, okay, this expression could be further simplified. And I said K is the same as Kc. I mean, there's nothing wrong. It's just an application, specific application for Kc. When you apply Kc to a weak acid, the weak acid is modeled as this thing. It's described as HX. this is your dissociation equation for a weak acid. So उसका बस जो Kc होगा, you just call it K, you just call it dissociation constant. So you've just given it a different name. That's about it. Weak. Remember, weak acid. I get your point. The point is that a weak acid is not about how many H+1 do you have. A weak acid is how much do you dissociate? Do you fully ionize or not? Okay, this is what a strong acid is. A weak acid is not determined by its pH. Okay, for example, I've got nitric acid over here, right? Now, nitric acid is a pretty strong acid, so it can have a low pH. So it's not about its concentration. Like if I go back and let me just correct this. Okay. So if nitric acid has an extremely low concentration, or 2-3 और zeros डाल देते हैं, ठीक है? So if it has a very low concentration, then obviously the H+1 concentration would also be very low. So it's going to be 0.0001 mole per dm cube. Now, if you try to take the negative log of this, so what would you get? You'll get a pH of 6. Now, that doesn't mean it's a weak acid. What a weak acid is, what a strong acid is, that it fully ionizes. So it is fully ionizing. It's only that you added so little nitric acid that obviously its pH is 6, but that still doesn't mean it's a weak acid. So the definition of an acid is that a strong acid will fully ionize. Now, the same could be applied to weak acid is by definition. So the same could be applied to ethanoic acid. Like if you had 25 mole per dm cube of ethanoic acid, or let's say you had 100 mole per dm cube of ethanoic acid, which is probably not possible, or it's got 1% ionized karta, you still get 1 mole per dm cube of H+. So you're still getting a lot of H+ ions. But the definition of a weak acid is that it's not going to fully ionize. Is this point clear? It's something like this. So the pH is not about like when we talk about the strength of the acid, it's about is it fully ionizing or is it weakly ionizing? pH just tells you about the concentration of the ions, which is a separate thing. So don't confuse pH with the strength of the acid. A weak acid can have a pH of 2, and a strong acid can have a pH of 6.5. So वो उसकी dilution के ऊपर depend करता है. So don't confuse, don't mix the two together. So remember strength. Summarize कर लेते हैं strength. Strength is about ionization. How much is it ionizing? That's how you're going to quantify it or qualify it as a strong or a weak acid. pH that depends on concentration a lot more than. pH का मुझे exactly मतलब P किसके start pH means negative log of H+1. Google कर लेते हैं. It's actually मैंने कभी किसी book में I haven't really potential of hydrogen. It is the potential of hydrogen, denoting potential of hydrogen. But remember, pH is the negative log of the concentration of H+1 ions. So it's basically the concentration of H+1 ions. बस उसका log दिया हुआ है. It's just the log of the कहाँ गया वो हमारा. Where is nitric acid? Just weak कर दिया था this one. So pH is kind of just concentration. It's just you're taking the log of the concentration. So you get this number is harder to plot. I told you why do they take log? The reason they take log is it's very hard to actually plot this number on a graph. Like in 6 को plot करना that's easy. So you express the concentration in powers of 10. So there's pretty much मतलब उसके पीछे कोई magic नहीं. It's just negative log of the concentration. So when you think of pH, think of concentration of H+1 ions. Alicia, is this clear? अच्छा, so coming back, किसका करना क्या? What's अच्छा, we had to derive another expression from this thing. So that's okay. So case in there's going to be another expression which is, if you look at any expression, if a weak acid ionizes, it will produce the quantity of H plus 1 and the quantity of OH ions that are going to be produced. OH H plus 1 or is a negative ion, whatever that negative ion is. They'll be produced in exactly the same quantity, right? जो मर्जी weak acid है. If this ionizes this one of this will be produced, one of this will be produced, same ratio, right? So any weak acid, if you ionize it, it's going to produce the same amount of H plus 1 and the same amount of X minus 1. That means H plus 1 and X minus 1 have exactly the same concentration. तो उसको दो दफा लिखने की क्या जरूरत है? They have exactly the same value. If this ionizes, let's say 0.01 mole per dm cube of H plus 1 is produced, then 0.01 mole per dm cube of X minus 1 will also be produced. तो ये दोनों एक ही quantity में produce होंगे. So the next thing is you can convert this into another expression, which is, so that expression is that your K will become equal to, just write H plus 1 squared. I mean, why write X minus 1? Because X minus 1 and H plus 1, ये वाला ion or ये वाला ion, they have exactly the same concentration. So why don't we just write H plus 1 and square it and divide it by the acid concentration. So that's my other expression, which is kind of the same expression, but I've just squared it. I've just written square. You clear? This one. Your expression clear? Over clear? See, Shahan, is this clear? So, अच्छा, उस expression से ज़्यादा you'll be actually be using this expression for a weak acid, and that's kind of your more important expression. That's going to be a more important expression. This is the one that's going to be used. अच्छा, फिर K की value पे थोड़ा सा comment कर ले. If you have a weak acid that ionizes more, so what will happen? If you've got a weak acid that ionizes more, produces more ions, will you have a higher value of K or a lower value of Ka? It was ज़्यादा ionize कर रहा है and produces more of these H plus 1 and X minus 1 ions. So do we have a bigger Ka value or a smaller Ka value? Anyone क्या होगा? It's constant for every acid. I'm just saying that if there is an acid, it's obviously a constant. It's not going to change. And every acid has a different Ka value. It's not going to be constant for every acid. Some acids will ionize more. Some acids will ionize less. Which acids they'll produce more H plus 1 and X minus 1 ions. Some of them will produce fewer H plus 1 and X minus 1 ions. So if you have an acid that produces more H plus 1 and X minus 1 ions, will the K value for it be bigger or smaller? So remember, K is not constant across the board. It's constant for a particular acid. Propanoic acid, ये K values है, ठीक है? K values for weak acids. So you've got lots of K values. So तो यहाँ पे the K value, benzoic acid, it's 6.4 times 10 power minus 5. Every acid has a different K value. It's going to be constant for that particular acid. So for stronger acids, it's going to be greater. So value vary करिए. Some of them it's going to be really small, like boric acids. So the smaller it is, the weaker it is. The bigger the value, इधर कहीं होगा कोई बड़ी value. अब इसको देखो, citric acid, it's like pretty sure that's wrong. It's not -5 होगा. Uric acid, that's 10 power -4. That's a strong, relatively strong acid. Propanoic acid -5 है. So the thing is कि आपका जो K है ना, that Ka is Ka large होगा. That means the acid is strong, or acid ionizes more. Although it's और K अगर weak होगा ना, that means the acid ionizes. So the acid ionizes less. So you'll have two things, that either acid ionizes more or acid ionizes less. But the weaker acid, you'll have variation. Some of them will ionize more, some of them will ionize less. So it will all depend. If they produce more H plus 1 ions, then obviously the numerator will be bigger. If they produce less H plus 1, the numerator is going to be smaller. और इसके बाद ये कि जिसके बाद जो चीजें हुई है कि all you have to do now is you'll have three things, and you can figure out if the acid concentration is given and you know the Ka value for the weak acid. So your table of contents दिया हुआ है, all weak acids will have a Ka value. जैसे H2PO4, अच्छा HSO4 -1 की मैं Ka value निकाल लेता हूँ. It's -1 dissociation constant value. तो ये दिया हुआ है, it's HSO4 -1, the K value is 1.2 times 10 power -2. So the K values will be given to you. So the K value given, acid concentration is also known. So what can you find out? You can figure out the H plus 1 concentration, right? If the H plus 1 concentration is given, the acid concentration is given, you can find out the K value. So तीन चीजों में से two things are known. You can easily find out the third thing. So it's pretty easy. It's just this formula. You just have to apply this formula. So we'll just do one question quickly, which is, let's say there's ethanoic acid, and there's 0.125 mole per dm cube. Ethanoic acid. And he's saying find the pH of this acid. Now remember, the problem was that H plus 1 we couldn't find directly, so we need the K value for ethanoic acid. So I'll just ethanoic acid K value. I'll just Google it. Paper में तो given होगा. That's 1.74 times 10 power -5. Anisha, it's going to be different. But every dissociation will be different. I mean, like if you have phosphoric acid, तो हमने कल discuss किया था ना, it's not. The first one will be different. The second one will be different. The third one will also be different. The same was the case with, I think, H2SO4 के बारे में भी यही होगा कि. But every time you're going to talk about one ionization, this will have a different K value. This one will have a different K value. This one will have a different Ka value. Achha, ethanoic acid. Ethanoic acid, the Google is telling me it's 1.74 times 10 power -5. That's the K value. So that would be given in the question. K is 1.74. Achha, times 10 power -5. How do you calculate pH? I'm just going to use K is equal to H plus 1 squared which gets divided by the acid concentration. So divide by acid concentration. So simply formula use करना, just put values into this formula and that's about it. Okay, so it's pretty simple. It's what's the K? It's 1.74 times 10 power minus 5. What's the other thing? Acid concentration is given, that's 0.125. Mole per dm cube, and you just have to find h plus 1. Right now it's squared. So h plus 1 की value बता दो ये क्या होगी. It's going to be 0.125. You just have to do the math. It's going to be 0.125 multiplied by 1.74 power minus 5. Office, you have to underroot the whole thing. So basically 0.6. You करके बता दे क्या आ रहा है. 1.75 e minus 5 multiplied by 0.125. So anyways, that's point. It's 1.47. H plus 1 is 1.47 times 10 power minus 3. So 1 mole per dm cube. And then you can easily calculate the pH as well. You just have to take the negative log of this thing. So if you calculate the negative log of this, you'll get pH. That's वो भी बता दो कि क्या आ रहा है. pH आ जाएगा. That's 2.83. Okay, so it's 2.83. So all you have to do is just remember this formula. It's that is going to be used for. This one is going to be used for weak acid, and they'll give you in the question that they'll give you the constant. I mean, they'll give you 2 out of 3 things. So you just have to find the third thing. That's about it. So the questions will be pretty simple. So ठीक है, इसके बाकी कल करके करते हैं. Yeah, I told you, see, मैंने कहा था pH का उससे कोई ताल्लुक नहीं है. pH is not telling you whether it's strong or weak. It just tells you that the concentration might be high. But अगर मैं concentration बढ़ा दूँ ना, the H% concentration would automatically be higher, right? जैसा वो nitric acid नहीं था, उसका pH 6 पे चला गया था. So pH is concentration. So the concentration could be high or low. It depends on how much water you are adding. Okay? So the pH does not tell you whether it's a weak acid or a strong acid. कि बहुत ही weak acid है ना, उसकी concentration बहुत high होगी, तो the pH will come out to be low. और बहुत ही strong acid है, उसकी concentration it's very low. That would mean that its pH would come out to be क्योंकि उसकी concentration low होगी, तो automatically H% भी low होगी. ऐसी भी बात समझ आइए वाली बात. The pH is not telling you whether it's a strong acid or a weak acid. It's the K value that's telling you. The strong acid का pH 6 आ सकता है, 6.9 भी आ सकता है. अगर मैं नाइट्रिक एसिड की concentration point मतलब बहुत ही कम कर लूँ तो वो 7 के करीब भी आ जाएगी. अच्छा चलो ठीक है, अब क्लियर है ना कि जो strength है ना of the acid, that is determined by K, how much it dissociates, how much it ionizes. The pH is more of a, you can think of it this way कि the pH is a function of, यहाँ पे देख लो, It requires जब H plus 1 की concentration निकालनी है, it's a function of how much it dissociates, plus it's also a function of concentration as well. कि अगर एक एसिड है वो आयनाइज ज्यादा कर रहा है तो उसका Ka ज्यादा है, plus its concentration is also high. So it's obviously going to have a very high concentration of H plus 1 ions. If there's an acid that's got a very low Ka value, which means it doesn't ionize much, but it's got a very strong concentration, तो तब भी H plus 1 ज़्यादा आएगा. So just remember, think of it, it's not K concentration doesn't matter or K, both of them actually matter in determining H plus 1. Is that point clear? तो एक तो उसे ionize करना है plus उसकी concentration क्या है, it's a function of both things, ठीक है? तो चलो ठीक है, ये कल फिर डिस्कस करते हैं, ठीक है? ओके, ठीक है, अल्लाह हाफिज़.